All right, so in our continuation of 6.2, now we're going to be moving into the stage where we are simplifying radical expressions. So those words are pretty close, rational and radical. So just remember, rational is that fractional exponent, so that's our exponential notation. And then radical expressions are radical notation. They're going to have like a square root symbol or a cube root or a fourth root or a fifth root. They're going to have some kind of root symbol in them. Okay, so you might have been wondering, why do we have to know how to convert from rational to radical notation? And the reason for that is that rational exponents, so rational exponents can be used to simplify, and here's the big thing, some radical expressions. So not all, but some. So I want you to kind of star that and keep that in mind, that we can simplify some radical expressions, but not all radical expressions can be simplified. So just be really careful with that. Okay, so when simplifying radical expressions, the very first thing you're going to want to do is rewrite that expression using rational exponents. So that's why we practice with that. And then once you have that expression in that exponential notation, all of those rules of exponents that we learned back in Module 3, we get to now use those rules to help us simplify. So I do want to remind you of what those rules are. So remember, if we have same base and we're multiplying, we get to add our exponents. If we have the same base and we are dividing, we get to keep that base and subtract our exponents. And I should have said that up here. You keep the base and you add the exponents. With division, you keep the base and you subtract the exponents. But again, it does have to be the same base. This is our power to a power rule. So base to a power raised to another power, we keep the base and we get to multiply those powers. And then I think in a previous video I said product to power rule when I meant power to power rule. And here, if we have a product raised to a power, then we get to raise each component of that product to that power. So a lot of people like to refer to this as kind of like a distributive property with that exponent, but you have to be very careful with that line of thinking, because this only applies with our product and our quotient. So notice that's not a plus sign and that's not a minus sign. So this rule doesn't apply to sums and differences, just products and quotients. So if I have a quotient raised to a power, each component of that quotient can be raised to that power. So just be very careful with 4 and 5 that you don't extend that rule into sums and differences, because it doesn't work that way. All right, so I'm going to stop this installment here and then pick up with our examples in the next installment.